Dear students, in the last session we have discussed about chemical properties. In that, the first chemical property was reaction of alcohols with active metals. So those reactions have explained about the acidity of alcohols. And the second chemical property is esterification. So the esterification is called as the formation of esters. So here alcohols are treated with carboxylic acids or acid anhydrides or acid chlorides. There is a formation of water corresponding the compound called as esters. So see here. So when alcohols on treatment with carboxylic acids, or we can also treat with acid anhydrides, or we can treat with acid chlorides also. Acid chlorides forms corresponding esters. For example, the first one is, let us go for general reaction here. The general representation of alcohols is ROH. And the general representation of carboxylic acids is what here? RCOOH. And here, alcohols on treatment with carboxylic acids in the presence of H2SO4 as a catalyst. H2SO4 as a what here? Catalyst. There is a formation of what? Esters. So the general formula of esters will be RCOOR. So this is called as what here? General representation of esters. So here, the hydrogen from the alcohols and OH from the carboxylic acids eliminated as H2O. Look at the reaction here. So this OH group and this corresponding H are eliminated as H2O, and there is a formation of the compound RCOOR. RCOO and then what here? R. So this is generally called as what here? Esters. We can go for an example. Replace this R group by any kind of alkyl group. I will take an example. CH3OH. This CH3OH is called as what? Methyl alcohol. It is treated with CH3COOH. This is called as acetic acid. This is called as methyl alcohol, and this is commonly called as what here? Acetic acid. Acetic acid. Hydrogen from the alcohol, OH group from the what here? Carboxylic acids eliminated as H2O. And there is a formation of what? The compound called as esters, CH3COOCH3. In the presence of acid as a catalyst, there is a formation of what? CH3COOCH3. So this is called as what? Ester, and this is commonly called as methyl acetate. Methyl acetate. And go for another one is reaction of alcohols with acid anhydrides. Similarly, the general representation of acid anhydrides is RCO twice O. So this is what is general representation of anhydrides. This can also be written as RC double bond O, O, and then what is C double bond O, R. Right? So this is written as RCO twice O. So in the presence of acid as a catalyst, and there is a formation of what is the corresponding esters here. Same. Hydrogen from the what here? Alcohols, and RCO from the what here? Corresponding anhydrides. Elimination of what takes place? Carboxylic acid with the formation of what? Esters. So here RCOOR. This is called as ester, and the byproduct will be corresponding carboxylic acids. Right? You can take some examples. Replace this R group by what? Any kind of alkyl groups. Similarly, go for treatment of alcohols with what? Acid chlorides. The general representation of alcohols is ROH, and the general representation of acid chlorides will be RCOCl. This is commonly called as what here? Acid chlorides. hydrogen from the alcohols, chlorine from the acid chlorides will be eliminated as HCl. See here, chlorine from the acid chlorides, hydrogen from the alcohols eliminated as HCl in the presence of water, pyridine. So here pyridine is the solvent which is used to remove this HCl. And what is the formation takes place? RCOOR. That is commonly called as ester. So this shows that again the breaking of bond between oxygen and then water, hydrogen of the corresponding alcohols. So this is another example. So in the last session we have discussed about acidity of alcohols, wherein we have also discussed what here the breaking of bond between hydrogen and oxygen. In this reaction also we are discussing about what the breaking of bond between hydrogen and oxygen. Okay. So the next reaction is third reaction. Reaction of alcohols with hydrogen halides, that is commonly written as HX, where HX is called as what here? Hydrogen halides. So here, when alcohols on treatment with hydrogen halide in the presence of anhydrous zinc chloride, there is a formation of alkyl halides. So here, when alcohols on treatment with hydrogen halides, HX is commonly called as what here? Hydrogen halides, where X is a halogen which can be taken as chlorine, bromine or iodine in the presence of anhydrous zinc chloride ZnCl2 forms alkyl halides. So that can be written as ROH is a general representation of alcohols. It is to be treated with water, hydrogen halide HX in the presence of water, anhydrous ZnCl2. There is a formation of what? Alkyl halides. So here, hydrogen from the OH from the corresponding alcohols and water, H from the corresponding water, hydrogen halides eliminates as H2O, and there is a formation of what? The compound called as alkyl halide, RX. We have to remove this OH and we have to remove this water, hydrogen. These two goes as water, H2O. And we are left with what here? R group and then what? X. That RX is commonly called as what here? Alkyl halides. And this reaction explains about what? Breaking of bond between alkyl group and OH group. So this was the reaction was explaining the breaking of bond between oxygen and hydrogen, and this is the reaction which is explaining what here? The breaking of bond between alkyl group and then what here? OH group. Right? So here, let us go for some example. Example, ethyl chloride C2H5OH, it is commonly called as water, ethyl alcohol, which is on treatment with what here? HCl. And taking instead of X as chlorine in the presence of water, anhydrous zinc chloride. What is the formation takes place? C2H5 and this is Cl combines together. There is a formation of what? C2H5Cl with the elimination of OH and then what this corresponding H combines together. There is an elimination of what here? H2O. This compound is called as what here? Ethyl chloride. This is called as what here? Ethyl chloride, right? So here, so on the basis of this reaction, we can distinguish primary alcohols, secondary alcohols, and then what are tertiary alcohol. So here, the mixture of HCl and anhydrous zinc chloride is commonly called as Lucas reagent. So here, the mixture of anhydrous ZnCl2 and concentrated HCl is called as Lucas reagent. Right? So we can also make use of for a dry HCl also. So This mixture, anhydrous ZnCl2 and concentrated HCl, is commonly called as what? Lucas reagent. Okay, so the mixture of anhydrous ZnCl2 and concentrated HCl is commonly called as what? Lucas reagent. So this Lucas reagent is used to distinguish primary, secondary and tertiary alcohols based on the formation of alkyl halide. So that is, we can see here, test and observation, type of alcohol, So the test is compound. So that compound may be primary alcohol or secondary alcohol or tertiary alcohol. That is called as compound. Plus we have to add what? Lucas reagent. As I have told you about the water Lucas, which is a mixture of ZnCl2 and concentrated HCl. So when the compound is mixed with Lucas reagent, there is a formation of alkyl halide. So that alkyl halide is, we take it as turbidity. Okay. So this, the alkyl halide as a turbidity, the formation of this turbidity takes place on the basis of what? Different kind of alcohols. Right? So if the turbidity appears immediately, that is, when the alcohol is treated with Lucas reagent, there is a formation of what? Turbidity, that is called as alkyl halide, which appears immediately, and that compound is commonly called as what? Tertiary alcohol. So therefore, tertiary alcohols on treatment with Lucas reagent, they forms a turbidity very immediately, and such type of alcohols are called as what? Tertiary alcohols. If the alcohol or the compound which is mixed with Lucas reagent, if the turbidity appears after 5 to 10 minutes, if the turbidity appears what? After 5 to 10 minutes, such type of alcohol is called as what? Secondary alcohol. Okay, and if the primary alcohol or the compound which is mixed with Lucas reagent, the turbidity appears only on heating. If there is an appearance of turbidity after heating, such type of compound or alcohol is called as what? Primary alcohol. So this shows that how the primary, secondary and tertiary alcohols can be distinguished by the help of Lucas reagent. If we mix a compound with the Lucas reagent, there is an appearance of a turbidity. If that turbidity appears very immediately, and that compound is called as tertiary alcohol. If the turbidity appears after 5 to 10 minutes, such type of alcohol is called as secondary alcohol. If the same turbidity appears only on heating, and that type of alcohol is called as what? Primary alcohol. Okay, and the next reaction is dehydration of alcohols. So this is one of the most important concept in this chapter, dehydration of alcohol. On this concept you are going to get about a 3 marks question, that is mechanism. How does dehydration of alcohols takes place? So here the name itself says that how the process takes place. Hydration, as I've explained in the last session, hydration means what? Addition of water. And here this is called as a dehydration. Dehydration means what? Removal of water from alcohols. Removal of water from alcohols forms corresponding alkenes. So here, when alcohols on treatment with dilute H2SO4 undergo dehydration. Dehydration means what here? Removal of water. Undergo dehydration forms corresponding alkenes. Let us take a simple example here. Ethanol. formula is CH3 CH2 OH, right? CH3 CH2 OH is called as what here? Ethanol. In the presence of what here? H2SO4 as a catalyst, there is a formation of what here? Alkenes, that is commonly called as what here? Ethene. CH2 double bond CH2, that is called as ethene with the elimination of what here? Water. So this reaction is called as dehydration of alcohols. So let us go for the mechanism. How does alcohol has been converted into alkenes, right? So this the same mechanism takes place as we have discussed in the case of what? Hydration of alcohols. So here the steps will be opposite to the corresponding water hydration of alcohols. So here the first step will be protonation of alcohol. The first step will be what here? Protonation of alcohol, and the second step is formation of carbocation. Second step is formation of carbocation, and the final step is what here? The formation of corresponding alkenes, right? So the mechanism is step 1. As I told you, the step 1 is what here? Formation of protonated alcohol, that is called as what here? Protonation of alcohol. Protonation of alcohol. So the protonation of alcohol forms the compound called as protonated alcohol. Protonated alcohol. So here compound is what here? CH3 CH2 OH. So the compound name is what here? Ethanol. This is on treatment with what here? Catalyst. The catalyst is what here? Corresponding dilute H2SO4. So the lone pair of electrons present on the oxygen atom of OH group takes up this proton towards it. So when this corresponding lone pair of electrons takes this proton towards them, this OH group becomes as what? OH2. OH with one more H becomes as what? OH2. And that compound is called as what here? Protonated alcohol. That becomes as CH3, CH2. This becomes as OH2. It was OH along with one more hydrogen becomes as what? OH2. So here oxygen is losing its one lone pair of electrons to accept this proton. Therefore, it will carry what here? Positive charge. So this is the alcohol which is having one extra proton. That's why this is called as what here? Protonated alcohol. Protonated alcohol. The second step is formation of carbocation. Step 2. Formation of carbocation. Formation of carbocation. As you know, carbocation means what here? The carbon which is carrying positive charge is called as carbocation. Here the compound is ethyl alcohol. Therefore, the formed carbocation is called as what? Ethyl carbocation. Ethyl carbocation. So see here the reaction. CH3, CH2, and then what here? OH2 plus. So in this step, elimination of water takes place. Elimination of water. So this is called as water H2O. So this is to be stable. If this wants to become a stable, we should remove this positive charge. So this positive charge is removed by giving these bond pair electrons to the oxygen atom. Therefore, there is elimination of water H2O. Since these shared pair of electrons are going with oxygen, therefore this carbon will carry water positive charge. That is written as CH3 CH2 plus with the elimination of water H2O. As I told you, the carbon is carrying water positive charge. That's why this is called as what here? Carbocation. So it is having water two carbon atoms and it is called as water ethyl carbocation. So this is the second step. And the final step and the third step is what here? Loss of proton forms a corresponding alkene. So the step 3 is formation of alkene or ethene. Formation of ethene. So that is this CH3, I will write it as CH2 and H. It is also CH3 and it can also be written in this way also. And what here? Single bond CH2 plus. And loss of proton takes place. The proton will be carrying what? A positive charge. We have to remove this H as H plus only. And these bond pair of electrons will be given to the what? Carbon having plus charge. As this carbon is having what? A plus charge, we have to reduce this plus charge. To reduce this plus charge, we have to give the electrons. So these paired electrons between carbon and hydrogen will be given to this carbon atom having what? Plus charge. Therefore, this positive charge goes off. There is a formation of carbon to carbon double bond. So this bond becomes here. So the compound will becomes as what is CH2, and this bond becomes as what? A double bond, and what is CH2. With the elimination of what here? This proton as H plus. So in the beginning we have used water H2SO4 as a catalyst that has been water regenerated, and this compound is called as water ethene, commonly called as water alkene. So we have water dehydrated the alcohol to water corresponding alkene, ethanol to ethene, through how many steps here? 3 steps. So this is the general example and this is the mechanism. In the mechanism, the first step is what here? Protonation of alcohol, which means that the proton is being added to the alcohol. There is a formation of what? Protonated alcohol. In the second step, elimination of water from the water, protonated alcohol forms corresponding carbocation. That is called as what here? Ethyl carbocation. And in the final step, formation of ethene. From the carbocation, elimination of proton takes place by the formation of what? Corresponding alkenes. So this is the what here? Mechanism of what? Dehydration of alcohols to alkenes. So this mechanism is always asked for what here? 3 marks, and this is much more important concept in this chapter.